Friends, welcome to GMK tutorials. In this video, we are going to see about the impulses and their properties. Generally, impulse means that it is a unit impulse of a continuous time variable. Suppose impulse function can be represented as del of t. So it can be represented del of t. This function where t is nothing but a continuous time variable, it can be represented as having a value of infinity at t is equal to 0 and 0 for otherwise. That means the signal is only existing at t is equal to 0 only. At t is equal to 0, it approaches to infinite value. Okay. So in the remaining cases, this value is equal to 0. This amplitude is approaches to infinity. So this is generally called the impulse function. We can also call as it is also Dirac delta function, where small t is nothing but continuous time variable. Continuous time variable. Okay, continuous time variable. So it is also can be represented as, so one more property of impulse function is nothing but it is also can be represented as, so integral minus infinity to infinity del of t dt is equal to 1. That means the area under the impulse function is also 1. That means, so it is only existing in this role. Suppose if you are taking this amplitude value is equal to 1 in this case, so from minus infinity to infinity, if you are summing all these values also, this value is only equal to 1. That means 0 plus 0 plus, so 1 plus 0 like this. So total value is also equal to 1. That means the area under the impulse function is also equal to 1. Moreover, impulse has the so-called shifting property with respect to integration. Impulse function is also having one of the important property, that is nothing but shifting property, that is nothing but integral minus infinity to infinity f of t into del of t dt. So this value is equal to f of 0. So that means this is only valid in this case. This is only valid in this case only. Why? Because that means this function is defined at del of t is equal to 0 only. When if you are taking t is equal to 0 means that this moreover this is also equal to f of 0. So one of the important properties is nothing but any function is multiplied with the impulse function, the resultant function is also equal to the same function with a shifted version. Okay, so because of this del of t is only existing at t is equal to 0, therefore at f of the value is equal to f of 0, where f of t is a continuous time variable and where t is a shifted interval is also 0. Okay, so one more property of the impulse function, shifting property, involves one more important property, that is nothing but so we can also defining another property, that is nothing but integral minus infinity to infinity f of t del of t minus t naught. That means here this function into is only valid. So we know that any function is multiplied by the impulse function, the resultant function is equal to f. That is very. Then now this interval is a very important. So from this basics of the impulse function, we know that this impulse function is existing only del of t is existing at 1 or maybe anything, it is t is equal to 0. So that means if t is equal to 0, then this function is different. So from this observation also, when t minus t naught value is equal to 0, this function del of t is valid. Therefore t minus t naught is equal to 0 means that t is equal to t naught. Therefore this value is equal to t naught. The t naught is also called the shifted interval. So this function is only valid in this consideration only. Then one more property of the impulse function can be represented as, for a discrete time domain representation, it can be represented as x in this variable. Generally, for discrete time representation, we are taking the variable as a n. So let us see one more important property. So just let us take some examples here. So that is nothing but here f of t is equal to cos of t and del of t minus pi. Okay. So from the shifting property del of t minus t, f of t into del of t minus pi into dt. So we know that from the basics of this function, it obviously it is equal to f. Okay. So f of pi. Okay. So here generally f means that is a cos function. Okay. Now, so cos of t means that so t value is equal to here equal to pi. Therefore cos pi is equal to minus 1. So the answer is minus 1. Okay. That is also very clear, right? So some more important observation here is nothing but some regarding information for a discrete time representation. For discrete time, general representation is n is a variable, but in our textbook point of view, we can follow as del of x that is equal to 1 for at x is equal to 0 and 0 for otherwise. Okay, 0 for otherwise. So in this case also the integration property in case of the discrete time can be represented n is equal to minus infinity, or else in case x is equal to minus infinity to infinity, del of x value is also equal to 1. Del of x is equal to del of x is equal to 1. This is also one more important. So as well as shifting property, another one is nothing but summing n is equal sum x is equal to so for a discrete time domain, here we are representing the textbook point of view, they can represent it as a x representation. Therefore x is equal to minus infinity to infinity f of x into del of x minus x naught, that is equal to the same function f with a shifted interval of x naught. These are the some of the important properties of the impulse function. Okay. Next, move on to some more important details regarding this one very clearly. So generally this is nothing but the function existing at this interval when 0 is equal to. Suppose if you are shifting this interval from here to here, that is nothing but a right shift. Okay, this value is only existing this particular event. So this is generally called the del of x minus x naught location. So a period of trains can be represented as s delta of t, that is nothing but train of pulses. So this is nothing but one position. Suppose the same scenario can be represented as a t naught like this. So it is a 0 interval. It is nothing but x naught, 2x naught location. So minus x naught. This is the general representation. So the same thing can be represented. So for that purpose, it can be represented as del of t minus n delta t. It is nothing but a train of pulses can be represented like this, where delta t is nothing but small interval. The graphical representation of this one is nothing but like this. So taking it is a del of t, yes, delta of t. So this is nothing but 0 delta t. So here n is equal to 1 delta t. So 2 delta t, 3 delta t. So here also minus delta t, minus 2 delta t. So this is a representation of a train of pulses. Okay. So it is also one of the most important concepts in case of the frequency domain. That means any function can be multiplied by the impulse function. The resultant function is also equal to the same function. Okay. So thank you guys. Thank you for watching GMK tutorial.